recording, and then I'll go ahead and introduce the speaker, and we'll get going. And the speaker said he's fine with questions during the talk. So if anyone wants to write anything in the chat or speak up. So it's my pleasure to introduce Robert Cavaliero today. It's very nice to have an alumni giving these talks. So very happy to have Robert here. He completed both his undergraduate degree and his master's degree at CU Denver, and also very excited to have a talk about in the civil engineering realm. So last year we were kind of more electrical engineering. We're kind of switching topics here. He'll be talking to us about improving concrete performance using carbon nanotubes. So please take it away, Robert.
Awesome. Thanks, Mark. Appreciate everyone's time today. Yeah, really excited to actually come back and do something back here at the university. So thank you for having me. I work just south of town down in Littleton for a company named Eden Innovations, and we make a product named EdenCrete, which is a pretty unique technology, especially for the concrete market. So I just thought it was a good opportunity to reach back out and just kind of share some stuff that we're doing, and also just to re-engage back with the school, as I've finally kind of gotten my head a little bit more out of the clouds and a little more along in my professional career. So it's exciting to do this. So we are a Colorado company. We are vertically integrated in that we manufacture carbon nanotubes. And we put those carbon nanotubes into different products that are used. And specifically today, I'll be talking about the EdenCrete product. EdenCrete's a liquid admixture. It's a liquid suspension of nanoparticles that is used in concrete to improve durability, fresh properties, a lot of different performance areas of concrete. We are located in Littleton, down just behind the Murdochs on South Santa Fe. So we are a Colorado company. We distribute this in 5,000-gallon tankers, all the way down to a 16-ounce bottle that we sell at Lowe's. We launched with Lowe's earlier this year, and they sell it to use for the pro and DIY customer to improve mortar and dirt, concrete products and masonry, shotcrete, that type of thing. Today in the presentation, I'll give you a little background on the company, the product. We'll talk about carbon nanotubes in general. We'll show you some performance results and testing along the way. And then we'll just go through some project applications. I understand we have some varying backgrounds here, and some may be into cement hydration and the Pozzolanic equation, and some might not have ever heard those types of things. So the majority of this is just to tell you a little bit about carbon nanotubes, and then to show you pictures of how concrete or shotcrete or things like that perform both with and without EdenCrete. And you can kind of make up your own opinion as far as how the performance is. But and then I'm welcome questions all the way throughout. I'll go through a lot of different projects here. I have more slides than I'll go through, but if you have questions about a specific type of concrete, shotcrete, DOT type application, if you bring that up, I'll certainly advance to that, and we can go through that if that's of interest. Otherwise, you guys can just kind of sit back and learn about carbon nanotubes and then see some concrete, and by all means, stop me anywhere along the way if anything needs clarity, okay? So like I said, we're located down in Littleton. We are, a Colorado-based company. We have a distribution headquarters or facility down in Augusta, Georgia. We do a lot of work down in the southeastern United States. And so they do repackaging, and they're basically a bulk supply facility for us. We sell EdenCrete both U.S. and internationally. We do have international work going on in France and Korea and Italy and China and a lot of different areas. EdenCrete is based on carbon nanotubes that we manufacture. It is ASTM C494 approved, conforms for a type S admixture. That just means that any architect or engineer can specify EdenCrete in any project without any concern. We have successfully passed the AASHTO NetPEP program, which is just a National Transportation Product Evaluation Program. And we work with NIOSH and OSHA quite regularly at our facility. We are the only commercial manufacturer of a carbon nanotube admixture for concrete. So there's not many facilities that are producing commercial scale carbon nanotubes. And nanoparticles in general are a respiratory risk. They're a carcinogen in the dry form. And so we work with EPA and OSHA. They come out, they check out our facility. NIOSH comes out because they don't have a lot of facilities they can go and look at. And so we allow them to run background monitoring and check things out. They can publish on our facility generically. And then if we need any more engineering controls, they will kind of interact back with us and help us to improve our facility if we need to do that to make sure everyone's safe within our facility. But we work with industrial hygienist groups, and we saw cut concrete, we demolition concrete, we spill EdenCrete on the ground, and we measure background air quality. And we've confirmed through several sources that the carbon nanotubes are not liberated or any sort of a respirable concern when they're in EdenCrete and in the hands of the customer. We are currently listed on 22 state DOT APL QPLs. We're being used actively by 3, one of which is Colorado. The ACPA has been recently put an article out on us promoting how carbon nanotubes are improving concrete pavement. This is a picture out on Vail Pass from a trial that we did a few months ago that I'll talk about as we get a little further in here. But that article can be found at this link if anyone is interested. So carbon nanotubes in general, right? Let me start with a nanometer. Take a meter divided by 1 billion. That's 1 nanometer, right? A carbon nanotube is a specific allotrope of carbon that has dimensions down on the nanoscale. So if we think about different types of carbon, we have diamond on the left here. It's a tetrahedral molecular shape. It's a 10 on the Mohs scale. It's the hardest element known to man. You take the lead in your pencil and look at that molecularly, and it's a lattice sheet structure. It's a 1 on the Mohs scale. It's very soft. Well, we grow carbon nanotubes, and we grow multi-walled carbon nanotubes. And that's to say, if you envision several varying diameters of seamless pipe, all inside one another if you're looking from the end, okay? And so we grow those, and it's these sp2 hybridization bonds that occur at the apex of these hexagonal interfaces that give carbon nanotubes these really strong, really incredible properties that make them appealing for a lot of different applications. What you see down here on the bottom right is a picture of ground carbon nanotubes after we've processed them. When we first open our reactor, they look like this here on the left. We're vertically integrated. We make a proprietary catalyst that we can make to make carbon nanofibers, carbon nanotubes, carbon black, whatever we want. We make that catalyst, we put it into our reactor. We use the process of pyrolysis with methane. We capture the carbon, we flare the hydrogen, and then we take those tiny nanoparticles and we process them into this black liquid here you see on the right that is named EdenCrete. Now, EdenCrete is not just a suspension of carbon nanotubes in water. Nanoparticles are hydrophobic. It takes a very special mechanical and chemical process in order to get them effectively dispersed and suspended to where they won't reagglomerate. I made suspensions when I was shortly out of grad school, and on Friday afternoon, they looked great. I'd make mortar, it looked awesome. And I'd come back in on Monday, and it was all carbon in the bottom and all latents on top, right? It's a very unique technology. You can't just stick nanoparticles into water and have a product. So this is that image I was promoting or proposing that you envision. This is just a CAD schematic. Now, we do not dictate the number of walls in our carbon nanotubes. There exist single-walled nanotubes, double-walled nanotubes, and multi-walled nanotubes, which could be a variety of different walls. And when you use single-walled or make single-walled or double-walled, you're constraining the number of walls, and that makes the process very expensive, right? So your cost-benefit threshold is it's more difficult to make it beneficial because it's so expensive to make carbon nanotubes. So we allow the number of walls to liberate. The properties of carbon nanotubes that make them appealing, they're conductive. Along all of the surface areas here, especially for you electrical engineers, you might find this more interesting. These carbon nanotubes are extremely conductive along the surfaces of all of the walls. Now, when we use them in concrete, we're not using the conductive aspect. We're using them for a multitude of reasons, but one is to make the concrete structure, the hardened cement paste matrix, more robust, more able to endure, right? More durable. And so the carbon nanotubes, when we think about comparing them to what we currently use to reinforce concrete, right? Steel reinforcement, steel rebar. It's 60 KSI or 60,000 PSI yield strength. Well, when we compare carbon nanotubes to steel, carbon is non-corrosive. They're inert. They're lighter. They're 1/6 the weight of steel. And when we look at the tensile capacity of 60 KSI steel compared to a carbon nanotube, the carbon nanotubes are anywhere from 100 to 300 times stronger in tensile capacity than steel. You know, one of our carbon nanotubes is anywhere from 10 to 50,000 times smaller than one piece of hair on your head. So here we have a transmission electron microscope image of a carbon nanotube. And this is not the end. It's just able to blast through and generate the cross section. But you can see these striations that are in the circumference here that indicate the individual walls. And you can see the hollow core section, right? A carbon nanotube that is put into a cement paste matrix provides benefits that are commonly provided in concrete using traditional macro fibers, microfibers, structural fibers. But we're doing this on a much smaller scale, right? The nano scale. So carbon nanotubes on average are a length of 200 nanometers and a diameter of 50. We produce a bell-shaped distribution of lengths and diameters. And there's a purpose for that. When you use rock or sand in concrete, you don't use one size particle of sand or one size particle of rock. You use a gradation, right? There's a particle packing phenomenon that's extremely effective in concrete. So we produce a bell shape, right? We're particle packing on the nano scale. When we look at another fiber that might be used in concrete industry, a PVA, they're 9.5 million in length and 14,000 in diameter, and they're dry. So when you throw a big pile of these into concrete, they absorb water. They make concrete harder to move. They make it harder to finish. They require you to add more water to pump it. EdenCrete is a liquid admixture that contains several quintillion carbon nanotubes in every gallon. That's times 10 to the 18th. Now, when we look at the carbon nanotubes and their function within the cement paste matrix, they're so small that their surface potential is almost negligible. And essentially that just means that, when we're making our product, we functionalize the carbon nanotubes. And essentially when they have such a low surface potential and they've been functionalized, they become good candidates for heterogeneous nucleation sites. And that just means that the cement can actually attach and hydrate around or encapsulate. And what you're looking at here on the right is a helium ion microscope image at 76,000 times magnification. And we've had our marketing group color this tube red. And what you can see is the dimpling on the surface there. And that's the cement having actually encapsulated or hydrated onto the carbon nanotube. And what that does is that provides a robustness and a safety factor, right? Those tubes are embedded, they're strong, they're a part of the hardened matrix, and it also prevents them from liberating when the concrete is demolition. A building's knocked down. Somebody kicks some EdenCrete up on the side of the road and it's been spilled, right? None of that is going to be a problem for anybody who's using the product. So essentially here on a scanning electron microscope image that's been lapped, what we're doing at a nano scale is we're physically arresting those cracks, right? The carbon nanotubes physically bridge those cracks, but there's so many of them in so many different orientations that they flood the cement paste matrix and they provide benefits in a multitude of ways that we honestly still learn more about. We call them happy accidents. So the benefits that EdenCrete provides that the mechanical aspect of the carbon nanotubes, right? We help to bridge cracks. We help to reduce shrinkage. We help to reduce curling, and we help to reduce the cracking that's associated with the concrete's response to that. So even for an identical level of shrinkage strain, we'll see that the concrete without EdenCrete might crack and the concrete with EdenCrete will not for a longer period of time, right? We don't make claims that we make crack-proof or indestructible or, concrete that you don't have to cure or joint. It's not what we do, right? You still have to use good NRMCA curing, jointing, batching practices. But if you do, the benefits from the nanotubes will help you with that top line there. The chemistry that's involved to keep these nanotubes suspended and keep a happy shelf life for a customer, that provides a unique benefit to concrete that helps with a lot of applications. For lack of a better description, it makes the concrete paste creamier. It makes it easier to pump. It makes it easier to finish. It makes it easier to get it through equipment. And so what that does is that makes it encourages better practice, because in the field, when concrete gets stiff, it doesn't pump well, it can't move, they can't finish it. The response is throw water on it, add water to the truck, add water this time, add water that time. And when you add water to concrete, you're messing with it, right? Concrete has been designed to have a certain compressive strength, certain properties based upon a water to cement ratio, the water divided by the cement weight. When you start adding water, whether it's on the surface or in the truck or in the pump, you're changing the water to cement ratio. You're also changing the color of the concrete. So when someone puts down concrete from truck to truck, which one batch is dry and one batch is smooth and one batch needs water and one doesn't, and one on the ground, you have these spotty sections where concrete looks different colors. You also have concrete that's a different water to cement ratio. Water to cement translates to strength. So in concrete, if you go out and look at your driveway and one section of it looks great and the other section, the top has started to peel off of it, that's the section that they threw the water on because they were in a hurry and about to go to lunch, and your concrete was getting a little stiff and hard for them to move. So that has benefits with ultra high performance concrete, pumping high rise construction. UHPC mixes can sometimes only be pumped for one story before they have to move the equipment. One story again, that takes a lot of time and money and slows down the construction schedule. We see mixes that can only go up one floor. We add EdenCrete, they can go to 3 floors, right? We've now cut the time, the schedule, the cost of moving that equipment down by 2/3, right? So there's a benefit. Shotcrete, it helps with the ability of it to adhere, that lowers the dust, it makes it rebound less, and it makes it lower the hydraulic pump pressure through the equipment. So equipment can run with less wear and tear, and they can pump more for a given gallon of gas, right? This is all sustainability. EdenCrete was created because of the strength, the toughness, the hardness of the carbon nanotubes. The bottom set of bullets is what EdenCrete was created for, right? It was about abrasion resistance, right? We keep the surface on for a longer period of time, right? If you're out on a highway or a bridge or in a parking lot, that's that broom time finish, right? That's those long straight lines. That's the resistance to your tires when you hit the brakes, right? That's safety. That's frictional resistance for the motoring public. Keeping that surface on is about keeping moisture out, right? When you look at concrete's internal structure, you see a lot of holes. When you look at the surface, you often don't see as many. So keeping that surface on helps to prevent the ingress and egress of moisture. The carbon nanotubes physically arrest those cracks, right? So they don't stop cracks, but when cracks occur, they will occur and be of a smaller size. And ultimately, the rate of propagation will be slower. And then the magnitude that they ultimately grow to will be smaller. So when we look at permeability, EdenCrete's integral. It's added during the batching process at the concrete plant. There's a lot of products that are topical. They're placed on top and finished into the surface, or during finishing or after finishing. And they help with the concrete, but only in a short top section, maybe 1/8 or 1/16 of an inch. EdenCrete's integral. And so we flood the cement paste matrix with all these nanoparticles, and we help to slow the ingress and the egress of moisture in and out of concrete. And in concrete, many of the deleterious things that cause the internal structure of concrete to fall apart are only caused from the presence of moisture, right? Alkali silica reaction, it requires moisture. Sulfate attack, it requires moisture. Corrosion of steel reinforcement has to have moisture. Leaching, when you see that white stuff running down the wall underneath a bridge of a vertical, that's got to have moisture, right? All of these require moisture. And in Colorado, one of the biggest, other than freeze or de-ice or chemical scaling, one of the biggest offenders of concrete is just freeze thaw damage, right? We can have 4 to 5 freeze thaw cycles in Colorado in a single day, right? Fargo, North Dakota, they freeze once, they don't thaw for 6 months. That's much easier on the concrete than freezing and thawing and freezing and thawing, and that water that's inside the microstructure expanding and damaging and then thawing and expanding and damaging and thawing, right? And then ultimately, if you can place the concrete, get it finished up well, and have these benefits that you see down here in the bottom, your concrete will last longer, right? We model this in service life software, but we see it on the ground, right? We see concrete that is placed well, that does not abrade easily, that does not crack as readily, that does not allow the ingress of moisture. It lasts longer. It looks newer for longer. And we saw this for years because people didn't specify us in projects, right? They said, okay, we've got 100 trucks that are going down. You can have 1 truck and we'll put you in there. So then we'd go out and we'd see this one section that looked great and all these other areas that had been worn down more severely in the same period of time. And so we were able to see that the durability is improved with EdenCrete, whether that's using accelerated testing or whether that's actually going through and looking at it within service performance. So there's 3 mechanisms by which EdenCrete can improve sustainability, and we're using it a lot with some big name customers. One is that the concrete or shotcrete will last longer before repair or replacement was required. I'll show you that in a couple projects here. The concrete mix design. We work with folks to actually optimize the mix design to lower the overall cementitious content and still achieve the design requirements, right? So lowering that carbon footprint. We also have been used to lower to improve the engineering design, right? You have a 4,000 PSI and it requires a 10-inch thick slab. We use EdenCrete in a 6,000 PSI slab and we reduce the thickness down to 9 inches. Across a big enough slab, that'll save hundreds of thousands of dollars per inch. And then you start saving volume of concrete, which translates exponentially to CO2, carbon footprint, sustainability. So some of the customer results. What we've seen is that some of our customers have seen reductions in CO2 by as much as 15%. We have customers that have seen project material costs ranging from 10 to 50% less. And then we have folks who are seeing concrete that will last longer by as much as 40%. And these are live because this concrete's still in service. So every year these numbers continue to grow, right? 40% will be 50% in a couple months. Depending upon the job, whether it's shotcrete, whether it's for a highway, whether it's for the airport, whether it's for United Airlines, whether it's for a manufacturing facility, the dosage changes, the design parameters change, and what we're able to accomplish changes. Okay, so it's a very unique thing. It's not your typical water reducer that just always reduces water, right? It's not your air entrainer. It's not your chemicals that have one benefit. We're a single liquid admixture that provide a suite of benefits, and we don't have compatibility problems with other admixtures. If you tried to accomplish what we're doing using other manufacturers, you would have to use things from multiple manufacturers, and you start getting interactions where the air entrainer has a problem with the set retardation, and then the strength gets delayed because of the retardation, so you need to lower the water. And you start battling these things that become a lot of challenges, and everything has a reaction, and you have to respond and adjust the mix. We're one admixture that works with all the other things out there, and we can help you to actually lower the usage of some of those admixtures as well to save money. So that's the end of the science aspect here. Does anyone have any questions or anything they'd like to discuss before I move into projects and some testing? Is the pace okay?
Yeah, I think pace is very good. Could you comment on for someone who's kind of ignorant? Are you guys you've made a great case how this is better and cheaper, saves money, right? Two questions I kind of had in my mind. Are you guys the only ones that have this? How does the competitive landscape look? And does this allow us, for example, to build, to really push the limit on things, not just save cost on things we do now, but like, can we have higher skyscrapers, right? I remember a couple of years, a long time ago, reading about how carbon nanotubes will let us build an elevator into space, right? Is that kind of where we're going to eventually?
We are the only commercial manufacturer of a carbon nanotube admixture for concrete. There are some other folks that make carbon nanotubes for electrical applications. You can use them for transistors and resistors and capacitors, but they have to be a very uniform length and diameter. So you achieve percolation threshold, right? A uniform network of conductivity through whatever media you put them in. That's not what we're going after with EdenCrete. We're looking for this random variety and orientation to bridge cracks and just get it in everywhere. We're not looking for that for this, right? We do use it in plastics overseas for some other reasons, but for this regard, that's what we're doing here. With regard to height, we would never tell you to use EdenCrete in a structural application in place of structural steel fiber. But there is an ability, we do testing, and we'll see the compressive and flexural strength increase. Not always, probably 40% of the times we do. You'll see, I didn't have compressive strength on this thing, right? But we get it probably 40 or 50% of the time, and we'll use it to optimize the design, and we'll use it to save money, to save CO2. But Mark, this is not always about saving money, right? There are times when if you want to do a more sustainable, a lower carbon footprint, a more, the economics are not always going to take you down to be cheaper, right? But I could show you ways that we've used it where they had no idea that what we were going to do was going to save them money and give them a carbon footprint improvement. And it's really kind of cool to see how that story develops here with some of these projects. So my point is, certainly with each floor, if the modulus of rupture of the concrete goes up, the required AS minimum of steel reinforcement could go down to a code minimum. And that's about weight, right? And usually, ultimately, when you get up so high, you start becoming limited on the overall weight down on the lower structure, right? So we could ultimately, with a higher modulus of rupture, use a small amount less of steel on every floor. And cumulatively, that would achieve, a great savings in weight. And when you have thinner decks, you can use a thinner gauge fluted deck. Your columns start to, shrink in footprint. And if you're somewhere like New York City, where you're doing high-rise construction, the value of a square foot can be several $1,000s, right? So you can take an inch or two off the diameter of a column. Now you're talking about adding small amounts of square foot back to some really high-end residential space, and you start, dangling some cheese in front of some engineers with that stuff. Good deal. Thanks for the questions, Mark. All right, so we've got a lot of customers, and the reason why, this is just a few of them, and the reasons why any customer are using EdenCrete very far and wide, right? Lowe's has got it out for their DIY and pro customers to improve bag products. Denver Broncos, every bit of concrete that goes to Empower Field has to have EdenCrete in it, specified by the engineer. We use it in place of Zypex integral waterproofer and in place of fibers. Bridgestone, I'll show you a project. We used it to in place of steel fiber on a large slab on grade, and we saved them a significant amount of concrete time and improvement on carbon footprint. United Airlines out at Denver International, there's a lot of concrete out on their maintenance apron and out on the runways that is starting to chip up. It chips up because of alkali silica reaction and things that happen due to some of the reactive aggregates that were used when they built the airport. They're replacing concrete because when they start up the engines of these planes at the maintenance hangar, it sucks chips up into the jets, and it causes millions of dollars of damage. We're being used now for that repair concrete in order to help prevent that. Colorado DOT, EdenCrete's and all the shotcrete that was just done on Central 70. We saved a significant amount of rock, sand, cement, things like that. And so we'll go through that as well. But the reason why any one customer might be using it could be sustainability, it could be cost, it could be safety, it could be durability, it could be any one of these reasons. And the dosage to which they might use can vary as well. Here's a list of the applications for which that EdenCrete's being used. You can see across DOTs, residential. We work with the Georgia Port Authority. We've got some government work going on for EMP mitigation, municipality. We work with Denver, commercial, industrial, you name it. EdenCrete's in it. Nanoscience is really kind of disrupting the market. So here's just a little bit of initial testing that we do that shows that helps to lend hand to why the performance happens in the field. So chloride ion diffusion coefficient is a function of permeability, right? We take a cylinder, we coat the sides, we put a 3% chloride solution on the surface, and we let it sit for a period of time. We then use a mill, and we mill off 1 millimeter or 2 millimeter sections, and we titrate that for levels of chloride as a function of depth down into the sample. When we look at this sample here on the far left, this was a mix that we did with just to test our products. So this is Colorado DOT's Class BZ Caisson mix. It's a very low permeable 0.31 mix. And it generates basically a graph of the concentration of chloride versus the depth, and then comes up with a coefficient. The reference achieved 28. When we added 1 gallon per yard of EdenCrete, the permeability dropped by 2/3. When we added one of our other products, the permeability dropped by about 19 times. The reason we run this is because carbon nanotubes are conductive. So there's a lot of methods like RCPT and other methods where you measure concrete permeability based upon conductivity or resistivity. You can't do that when you have a product that's conductive like a carbon nanotube. So this takes a function and looks at percolation and thresholds and removes resistivity. One reason why we do this is because you can then take these coefficients and plug it into Life 365 and model service life and years to steel corrosion. When we plug this in, we see that the control mix had a years to critical corrosion of steel of 10.5. EdenCrete extended that by almost 2 to 19.6. When we look at service life, the service life was extended from 16.5 to 25.6. You're talking about making decisions today when your budgets are tight and trying to decide, is it worth putting this value add product, right? It might cost me a little money, but I may not have to replace it for twice as long. Where's the value? What am I focused on, right? What's sustainability? Durability is sustainability. If you can make concrete last longer, it will be more durable. If you don't have to put resources towards it to repair or replace it, it will be more sustainable, right? For every 1 pound of cement that's manufactured in the industry, we emit 0.927 pounds of CO2. Second only to a coal burning power plant. We are the second worst offender of CO2 for our manufacturing process of cement of the world. We are 7 to 9% of the world's greenhouse gases. This is very bad, right? Our other product, you can see, took it up a magnitude in order of 8, and almost the same there with service life. When we look in the field and we start to see how some of this single property translates. This was the first concrete we ever put EdenCrete into, first truck we ever put EdenCrete into concrete. This was a residential stormwater or a residential townhome community expansion in Aurora. They were basically have an asphalt parking lot with stormwater drainage systems. We put EdenCrete in one truck. We didn't put EdenCrete in the other. When we went out and we looked at it after 1 year, we could see that the section without EdenCrete was already severely abraded, pitted, scaled. It was cracked on the edges. This area is subject to, snow plows, commercial trash trucks, all the residents that live there. And we saw that the EdenCrete section still was in great shape with the broom tine finish. When we went out there 3 years later and took pictures from the exact same location, we could see a continued exponential decay of that reference versus the EdenCrete. I went out there last year and there was only one section left that didn't contain EdenCrete, and it butted up right to an EdenCrete section. It doesn't even look like concrete anymore. Now, while this is not the majority of the world's concrete placements, this demonstrates a lot, right? It demonstrates a resistance to abrasion. There's rocks and things that ferry down through the water, a resistance to water abrasion, a resistance to de-icer chemicals, a resistance to cracking, and a resistance to the scaling of the surface staying on there, right? So a very simple application, which demonstrates a significant amount about cross applicability, right? We've been in service for 7 years and our sections have not been replaced. So we're already 50 to 100% longer in service life than them. They use $600 for the EdenCrete in one truck, and there was one other truck. They've been out there for 2 separate projects to remove the concrete without EdenCrete. I'm sure at a cost greater than $600. So they could have paid $1,200 instead of $600 and put EdenCrete and everything and have never been out there to date. Instead, they've had to come out for 2 different projects to remove 2 different large sections of concrete without EdenCrete, and they placed it back without EdenCrete. So most likely they'll be out there replacing it again sometime in the next few years, just because they weren't a part of the trial and it was just an application area to be able to use it. We keep it in Colorado. We go up to the mountains and we look at Bachelor's Gulch up in Beaver Creek. They're very strict on the way that they allow their curbs to become damaged. And at the entrance to Bachelor's Gulch, they have a log cabin that they get to sit in. So it's a very high-end community. They're exposed to a lot of de-icer chemical, snow plows and things. And so we put EdenCrete in one truck and we didn't put EdenCrete in the other. And we were replacing sections that looked like this. So, they don't look great. But if the dirt wasn't here and these were clean, these are really not terrible relative to what you see in service. So when we went out and we poured EdenCrete, we poured the other section on the same day. We could see that if you look at the pictures one over the other, at 2 months, the reference section was already damaged. EdenCrete still looked great. At 2 years, the reference continued. EdenCrete still looked great. I went back out there 2 months ago. The reference continues to decay, and the EdenCrete, it's not perfect, but it's far from what the reference is, right? When we look at these at a little closer up image, you could see how much that capillary structure is opened up on the reference, right? That stuff's not going to last much longer, and it's going to have to completely be removed. And they'll be lucky if snowplow doesn't go off the road because the curving fails. So you talk about aesthetics, you talk about general satisfaction of your customers, your residents, and ultimately you talk about safety, right? So that demonstrates performance up in cold weather climates, de-icer chemicals, those types of applications. We also work with the DOTs quite a bit. One of our first jobs down in Georgia, whenever we were acquiring land down there, was to work with Georgia DOT. And they pour these full depth slab replacements out on the highway, and they have a very clay soil, and the Savannah River is nearby. And so the water table comes up and laterally washes out the subbase underneath the concrete. So when we pull these slabs out, there's no subbase in different sections, and they essentially have an elevated slab or a suspended slab. It's not just a slab laying on rock. So we went out and we learned of the challenges. You can see in this lower picture, they pour sections and replace them. It might be a 4-foot section, an 8-foot section, a 2-foot section. They just replace whatever comes up that's damaged, right? So we went out, we did 16 yards with EdenCrete, 16 yards without. Now, when we went out there about 4 months after placement, we could see what we've seen before in that the concrete with EdenCrete, the surface was still much more intact. The broom tine finish is still in place. The edges and the joints are still intact. When you look at the reference, it's stained, it's abraded smooth, the joints are cracked, the edges are raveled, and it's got a large crack going through the center area here that proceeds from joint to joint. We also did lab testing in parallel, and we saw that the EdenCrete had actually improved the compressive strength about 30% across all ages. We wanted to demonstrate to them how much it improved the abrasion resistance. And so we ran a test where you take a concrete cylinder shown here on the right, and you take these steel ball bearings, which are facing the ground, and you push them into that concrete, and they spin at 1100 RPM with a 27-pound force. And there's water used to help the abrasion. And you plot the depth of abrasion versus time. It's a 20-minute test shown on the x-axis, the depth of abrasion shown on the y. And we see that EdenCrete in the red came over and achieved this depth of abrasion. It achieved a depth of abrasion 50% better than what the reference achieved. What's more important to notice is that if you follow this gray line over, the depth of abrasion that EdenCrete achieved at the end of the test is the depth of abrasion that their high-strength early concrete achieved in 2.5 minutes of the test. So while you can't use this as service life indicator, what you typically see in the field is pretty demonstrative of what you're seeing in the test data. So we then worked with them to demonstrate that we could help them optimize their mix. Their standard mix is 752 pounds of cement per cubic yard. It's a 0.46, and it has no EdenCrete. So we ran testing and tested compressive strength. We then dropped the cement 112 pounds, added 1 gallon of EdenCrete. We saw that the strengths were comparable. So we kept going down, dropped another 30, kept the EdenCrete, dropped a little bit. So then we increased the chloride a little bit, and we brought it back to a good number here that we felt safe with. We dropped 192 pounds of cement per cubic yard out of this mix. We then ran set times, and we saw that initial set was negligibly affected, and final set was 90 minutes sooner. Right, so this would allow them to get traffic control off the road 90 minutes sooner, saving money, saving traffic, saving a lot of different things that cause problems out on the highway when you're driving home. Ultimately, we were added to their QPL. They wrote us into the maintenance specification by name, and they use EdenCrete to save 15% of the cement across the concrete. We also move into bridge decks, right? Bridge deck applications are plagued with challenges, right? You've got suspended slabs. They experience a lot of frequency, a lot of bending. Cracking is inherently a problem. So we went down and we learned of the delays in their construction schedule, why they wait for the concrete to obtain strength. So we went down and we did a trial, and they put EdenCrete in the first 2 spans, and we actually achieved the design compressive strength in 4 days. Their mixes were typically achieving it in about 22 days. Ultimately, the fresh properties that EdenCrete improves helped with the placement with this slip form paver to get the concrete down without adding water and without adding to add water to the surface, causing any problems with the ultimate durability. The other thing here is that this is how they poured span 2. This is span 2 poured 1 month after our span was poured. So 26 days after we achieved the design compressive strength. They're removing this bridge because it's structurally deficient. It doesn't seem like it makes sense to put the motoring public, traffic control, a concrete truck, and a concrete pump truck on top of a structurally deficient bridge to pump to a new bridge when your first span has already exceeded the design strength that's required for the bridge to open to service. So we go after the idea of stop putting public in bad situations, move the equipment over to span 1, save on the time and the expense of traffic control. You don't cause traffic back in the area in a small rural area like this. And ultimately, you accelerate the construction schedule, right? This could be used to save 4 months off the construction schedule for a bridge that's going to be taken out of service for over 8 months, right? You're talking about 50% saving. We actually went back out, and I just went out with a group the other day, or a couple months ago, and we pulled cores. We ran that chloride ion diffusion test. And what we're seeing is that with EdenCrete, we had 2 spans, and we have an average of 4.35, but ultimately, we see that 1 span did really well and has a 60% improvement over the reference, which is the GDOT Class D. The second one has a 22% improvement. So when we average that, we have a 41% improvement in permeability over the reference for a bridge deck that's reinforced with structural steel, right? That saves on chloride corrosion. That's a life safety issue, right? We're talking about durability and long-term performance of that bridge, right? So that's what we intend to do or try to do with some bridge applications. We work with Colorado DOT as well. I mentioned that, you know, there's topically applied products, right? Some of them are used to improve the hardness of the surface. Some are used to improve the ability to finish the surface. Some are used for both. They're used at a lower dose just for finishing, and you increase that dosage for a harder surface. But those take time to apply. The concrete has to be placed, it has to be finished, and then these products have to be put on top. And so that takes additional time and keeps the roads closed for a longer period of time. And ultimately, topically, we applied products only improve the top surface. So this is a product made by Solomon Colors named Day One, or Lithic Day One. And like I said, it's used to improve the resistance to abrasion, scaling, as well as to improve finishing. So when we look at compressive strength versus the EdenCrete dosage increase, you see what you would expect, right? The Lithic Day One is topical. It does not improve the compressive strength of the full depth of the concrete. When you look and you add EdenCrete, you see the improvements in strength start to go up into double digits. When we look at abrasion resistance, which is the reason this product was used by Colorado DOT, and we look at one of these tests, we look here that the reference lost 7.2 grams after the test. The product intended to improve abrasion resistance lost 6.6. It improved 8.4%. And then when we used EdenCrete, we saw those drop and would begin to get into double-digit improvements again, right? And so this is about long-term performance, resistance, right? Being able to endure what's going on out there over time before more resources have to be put back to it.
Hey, Robert, can I stop you for a second? We have one one participant, Hector Aguirre, wanted to ask a question.
Yes, please.
Go ahead, Hector.
Hello. Hello, I'm Hector. I'm pretty familiar with the concrete world. My father owns a concrete flatworking company, so we usually do residential flat work, and yes, occasionally we replace commercial work as well. I just have a couple questions. I'll start with one. How does EdenCrete improve, I guess, concrete curing in extreme conditions? So we often pour, in below freezing temperatures. So you're trying to beat the concrete from freezing while you're, finishing and prepping it in order to blanket it and stuff. So how does this improve, I guess, concrete strength and resistance from freezing, especially in cold weather?
No influence. It's not like I said earlier, you still use the same NRMCA curing, jointing, finishing. You use all of the same practices that you would use. But if you do things correctly, your concrete is going to be more robust and more durable. But we are not something that's designed to accelerate curing, reduce curing, prevent freezing. Man, you got water in concrete, it's going to freeze. I mean, you can use 140 degree water.
You do use other protocols such as ground heaters, and we use calcium chloride and all that stuff. But sure. I was just wondering if it ever affects or benefits the concrete in like a way of resistance from freezing.
Hector, what we see when someone uses like an NCA or CNI or anything like that, it's weird. We haven't figured out exactly why it's happening. But if you have a mix that's accelerated, and you've got some accelerator just to kind of give it a little push because it's going to be cold, right? It's whatever. If you have accelerator in there that gives it a little push, when you use EdenCrete with that accelerator, it turns that push into a shove. That's the best explanation. We have folks that they use 3 gallons per yard of CNI and precast. They use EdenCrete. They only use 1 gallon per yard of CNI, right? Okay. They use 2% of NC. They use EdenCrete. They use 1% or 0.5%, right? And again, that's not because we're resisting the freezing. It's just because they're able to achieve the strength, and we have a synergy with that. And ultimately, that's accelerate. Yes, sir.
Okay, one more question. And so when you say about those topical additives, we use for a lot of our city work, we use white wax cure. Day One is another one that we also use because a lot of our work is hand finished. Are you saying that we don't need the white wax cure upon use of EdenCrete?
So it depends on what you're using the sealer for, right? If you're using something as a finishing aid, we have a lot of folks that will use EdenCrete without because they don't need the finishing aid as much. And then when they do, they use less of the finishing aid. When you're talking about the Vox, is that the Euclid product, that VOX?
It's white wax cure. I think it is the Euclid product.
Depending upon what your base concrete is that you're using, right? Because we're putting EdenCrete into mixes. We're not coming and saying, hey, you have to use the EdenCrete mix, right? We don't come and say, we need to do a 6-month-long study so you can use EdenCrete. We come to you and you say, I have a mix that's in a spec. What am I going to do? We say you add a gallon of EdenCrete, or you add a half gallon of EdenCrete.
Oh yeah, definitely.
And that's it, right? And we go and we reduce the design water content for the volume of EdenCrete that goes in there so that your water to cement ratio stays on time with what the design is. EdenCrete's 95% water.
Okay.
Sorry.
Okay.
So you just assume it like water when you're doing your designs in your mix. You'll just substitute your design water for the amount of EdenCrete that's in there.
For the amount of EdenCrete. Okay. So that
Yes,
doesn't
sir.
affect slump or anything, you know.
So what we see, Hector, is that the fresh properties are improved. If you need a 6-inch without Edencrete, you could do it with a 4-inch with Edencrete. We have
With
guys
EdenCrete.
that they have
Okay. I
truck pull,
see.
a truck pulls up and it's a 5-inch and they had 10 gallons of water. It's a 4-inch, they had 20 gallons of water. Trucks pull up with
Correct.
Edencrete, they'll let it drop to a 4 and they'll dump it out before they start messing with any water. If you need water, Edencrete will help it take that water, endure that, fewer color changes, and help you to have a more consistent strength. But we're not going to require the need for water as readily as what a conventional mix would.
As readily as okay, I understand. Sweet. All right. Well, thank you for answering my questions. I appreciate it.
Yeah, of course. Please stop me anywhere along the way. All right. So let me go through these. I'm gonna try to go through fast because I want to get through a couple of these. So Denver, City and County of Denver. They use EdenCrete for de-icer chemical scaling resistance. This is down on Spear Boulevard where Spear and Broadway and the Raceway come off to where the Spear comes out of the tunnel when you're heading down towards Cherry Creek. We did 1 lane with 2 gallons per yard of EdenCrete and 1 lane with 3 gallons per yard. We just simply added it on top of the CDOT Class P mix. We ran de-icer chemical scaling, which is a combination of ASTM C672 with another Canadian standard. And first you do a visual rating of the surface and how far scaled it is, 0 being no scaling and 5 being severe with coarse aggregate visible. When we looked at these samples, this were done by Martin Marietta. They have a concrete plant down on Cuivas. You can see the reference has a lot of dark sections. That's where the concrete is actually delaminated and scaled. And the EdenCrete section actually maintained and has a better visual rating. When we actually take the metric and we combine what was lost, we see the mass loss from the reference 27.86 to the EdenCretes of a drop of like 17% and almost 30%. And so City and County of Denver, we've been out there several times. They've actually had some of their summer work, after summer guys going out there and dumping mag chloride on it, even in the summer, just to try to accelerate and see what it can take. And we went out there and we walked the project with Dottie's engineer, Amy Strahopoulos, and she wrote us a letter saying EdenCrete is significantly improving the performance of Denver's concrete and that it should be used for future projects and in spec work. This was another one where it's a mix that we achieved the design in only 24 hours, and it was supposed to hit it in 72 hours. So they were able to open that section of concrete or that section there 2 days sooner than what they would have originally. Again, de-icer chemical scaling against something like Impede. You can see not a lot of scaling here, but more than anything else. And then the EdenCrete comes over here and works as well as an integral waterproofer. We did a project trial out with Colorado DOT in Region 3 of Colorado. They only use asphalt pavement because of challenges with timing to construct concrete, delays with traffic from ski people, skiing and those folks going in and out. And so we're trying to convince them to start using concrete pavement because while asphalt only costs about 60% of what concrete does, it also only lasts about 1/3 the life before it has to be milled and you have to start doing maintenance to it. So we went out to do a project against the 4,500 PSI CDOT Class P paving against a 7% silica fume mix. And when we've gone back out there, it's been in service 1 year. We can see that the Class P mix is already cracked over here on this corner. It's got a lot of scaling going on and the surface is pretty beat up. The silica fume section, again, we've got cracks. We've got edges here that have started to break from commercial vehicles and the surface is opened up. And the EdenCrete, we have no cracking. We've got a minimal amount of abrasion down here on this far end. And in the middle section, it is much less. And then over here, we've got a little bit more, but we have no cracking within the field or on any of the edges. And so we're 1 year into a 3-year evaluation. And ultimately, we're trying to convince CDOT to start using concrete pavement out in Region 3 for the benefit of everybody, really. But so we'll see how that goes. 2 more years. And this is what ACPA did their article on. So in the end, we looked at EdenCrete did have a little bit of abrasion there, but we had a no on the other aspects, and the reference in the silica fume are doing worse, and silica fume's a respirable concern as well. All right, industrial. So United Airlines, I talked about, they have those, see the concrete damage out here. They're constantly repairing large sections, and they've been doing this for years, but now EdenCrete's in the mix. So we've been doing that now for about 3 years with them. We've just been specified into their, I don't know if you all are familiar, but United is expanding their training facility over in Stapleton. And they've just specified EdenCrete in that entire facility. And they're placing 12 new flight simulators that'll sit on top of these 4-foot tall concrete pads. And it's going to be a pretty incredible expansion that they're doing over there. But we seem to be in there good with United's engineers, and they like what we're doing for their concrete. Michelin and their manufacturing facilities, this is an extruding facility, and they often take individual sections within the concrete and they use a metallic dry shake hardener. If you're not familiar with a metallic dry shake hardener, it's essentially iron oxide shavings that are embedded with a very finely ground calcium aluminate cement, or a high aluminate cement. So it's a very high strength, fast, high reactivity, thin layer of cement that has metal shavings in it. And that stuff has to be applied after the concrete finishes and the concrete bleeds. So just like the other product, it takes additional time and labor. The building has to stay open for longer. There's a lot more that is involved when you do that. So if you can remove the need for a metallic dry shake hardener, you make a lot of things better for everyone on the job, right? You don't need the building to be open as long. You don't have to wait as long to finish it. You can finish the concrete and be off of it. And there's less liability, right? Those dry shakes are going on top of, say, a 4,000 PSI concrete, and they say they make it 10,000. Well, you got a guy throwing it out there by hand. The likelihood that he gets 1 pound on every square foot across a 200,000 square foot slab is challenging. So what happens when you don't get enough in one area? It's not 10,000 PSI. Maybe it's 6,000 PSI. Maybe it's only 4. And so you get into these industrial areas where the top surface gets damaged. That top material gets chipped off. And now it may as well be an epoxy, because now you're down into the 4,000 PSI concrete, and it's going to start damaging and growing outward from that location. So we ran abrasion resistance, that same test I showed you earlier, and we ran it against the Euclid products that Michelin typically use. And we saw that EdenCrete improved the resistance to abrasion by 20% over both of the products. For the product they use in the interior application, EdenCrete is 50% of the cost of the dry shake hardener. Now, guys, we saw this. Remember I said compressive strength. It might be there, it might not. Less than 10% compressive strength is 0% improvement in my mind. Here we had a 20% improvement to abrasion resistance with a 0% improvement to compressive strength. Conventional wisdom has said better abrasion resistance, harder concrete, right? And that's not what's going on in the world today with nanoparticles. So here we were able to pump it a much longer distance. The concrete did not get clogged in the pump. And again, we were able to do that at a lower hydraulic pump pressure, saving fuel across the project. When they get done, they're able to bring the cream up to the surface fast enough that they don't have to burn it. So when they're tasked with a burnished finish, like your garage, you often see it's black, it's a dark gray. They're able to get the cream up fast enough with EdenCrete that they can get this almost marbled look, because they can do it before it burns it. And in an interior lighted application, it really takes on a cool effect across the large scale. So for Bridgestone and their off-road tire manufacturing facility in South Carolina, they manufacture some tires that are about 18,000 pounds a piece. And they have to be moved with a forklift that moves one at a time. So it's a rolling load of about 30,000 pounds that's actually rolling out here across the slab. And so this slab is used for nothing more than to stage the large heavy tires before a large flatbed is going to take them and take them off for a customer. So we went out and we put EdenCrete into a design that was a 4,000 PSI, and the mix hit 6,000 PSI at 28 days, and it hit 8,000 at 56 days. When we went back and we worked with the engineer at Cranston Associates, he actually, we used that to optimize the design. We reduced the thickness of a 10-inch thick slab by 3/4 of an inch. The slab totally was 165,000 square feet. So by saving that 3/4 of an inch off of that, it saved 570 cubic yards of concrete. We ultimately saved $33,000 across the all difference, all in. The cement saved from 570 yards of concrete was about 340,000 pounds. And when you think about almost 1-to-1 CO2 production for cement production, just in the savings of cement alone, we saved over 157 tons of CO2 from the project. When you consider what all was going on out here in those 570 yards. We saved 330,000 pounds of cement. We also saved 600,000 pounds of sand and 1 million pounds of rock, and all of the associated CO2 with the mining, the coring, and the transport of those. And oh yeah, 57 fewer concrete trucks had to go out to Bridgestone's facility, saving all of the fuel and all of the headache and all of the challenge of 57 more trucks having to go out there for another day's placement. This is a rail car repair facility named TTX down in South Carolina. They own a fleet of train cars that they lease to all the big players, the BNSF, the CSX, and they have 3 facilities around the country where they repair their train cars. And this is one where you can see the concrete out here in this facility is badly damaged. This place has been here for 50 years. The contractor, he cut his teeth 30 years ago walking onto his dad's job because his dad did the work out here for 25 years before he took it over 5 years ago. So he's seen this concrete being damaged, and he's starting to replace concrete that is newer, and concrete that's older looks better. So we went out and we did a trial. We poured a section without EdenCrete right here on one day, and we came out and we poured a section with EdenCrete over here the next. And this was chosen because of the entryway, and all these trucks pull in. They drive over part of both of these slabs. They stage, and then they back up. They dump their 40,000-pound trailer, and then they drive out over the EdenCrete one, over the reference, and back out the gate. Every day they get 15 to 20 of these deliveries. So we went out, we just basically wanted to show them they could do it faster and easier. So we got him, so we went out after we did our placement, and after 4 months, we saw that the EdenCrete section, the broom tine finish was still there. It was brighter. It was not cracked. It was not scaled. And it looked just like a newer piece of concrete. The reference section had cracking. It was abraded. It was scaled. The owner asked this guy, "What did you do out here? What have you been doing for 30 years?" He says, "Well, it's about a 14-inch excavation. I do a 6-inch of GAB to 95%. And then I do an 8.5-inch thick slab with welded wire mesh and 4.5 pounds per cubic yard of fiber. It costs you $15 per square foot." And he says, "Go talk to your engineer. Find some engineering design that he'll put his name to that's going to give me 5 years." He says, "Okay, no problem. You just need to excavate 24 inches and give me 6 inches of coarse soil compacted, 6 inches of GAB compacted, and a 12-inch thick slab with number 4 on steel. It'll only cost you $22 per square foot." And he says, "Well, what did you do with EdenCrete?" He says, "Well, I ripped out about 6 inches. In some areas it's 4, some areas it's 7. I basically used macro fiber with no welded wire mesh, and I poured it back." And these are the types of jobs that they do. They rip out sections. They leave the water still in the hole from the wet saw. They don't compact. They don't get a uniform thickness. And they've been doing this now for 6 years. This is over a sidewalk with a crack. They just put a 2x6 for. I mean, this is nothing you would ever think somebody would be doing for concrete. And it performs dynamite. They require EdenCrete in all of the concrete that goes on out there. They use it in these sections under large filtration systems, these areas that go back to the inventory yard. This slab has typically been replaced every year for the 30 years that Brett was working out there. It's only not been replaced the last 6 since it's had EdenCrete in there. It's the same slab we poured back then. This is up in Metro Mix plant up north, their concrete plant up on 58th Avenue. We went in and they were going to be taking out a large entryway here of their concrete plant, which was going to cost them business from Wednesday through Monday. And this is an access way between a large countertop area and a metalworking shop. And so they were going to take this large section out because they needed to rip it out on Wednesday, pour it back on Thursday, and it needed to cure until Sunday so they could open to Monday without ripping the surface off of this. So we said, look, why don't we go in, you rip out the reference on Wednesday, keep the other section in place till Friday. Rip that on Friday after you're done with business. Put EdenCrete back in there. Open them both up on Monday. So the EdenCrete section kept you in business, kept you generating revenue, and it kept you out of service for 2 less days. And when we opened it up and we go back out and we look, we see this. Like I said, we are not indestructible, but this is a shared joint. This is EdenCrete on the right. This is not EdenCrete on the left. And some event has occurred that's caused that level of damage on that one and not the EdenCrete. And you can see similar up here on this one right here. So Hector, we went from there and we basically developed a line of mixes where we use EdenCrete in place of fibers or in lieu of with fibers or in lieu. And we've gone out, we've developed a whole series of mixes, and those fibers lay down. They embed very well in the cream. You don't have to burn them off. You can finish your joints and you can cut down on fiber dosages, things that make the world of flat work finishing a better place, right? So shotcrete. We started putting EdenCrete into shotcrete. We realized that suddenly it did not produce as much dust. It stuck to the wall better. We could see this visually when we went out onto a job. A hydraulic pump would be running at 3,800 PSI pressure. We put EdenCrete trucks up to it. It drops to 2,400 PSI on its own because it's easier to pump, right? We go to interior applications. This means that folks can actually use more than one applicator on an interior application. This job was supposed to be one applicator. It was scheduled for 4 days. They actually ended up adding a second applicator. We knocked it out in 3 days. So we saved it by 1 full day, right? That's air quality, that's safety, that's speed of construction. We went out and when we look at this and we look, if you've ever seen shotcrete placed, nope, that one won't work. That's okay. So CDOT's Central 70 project, they had awarded the bid to Aggregate Industries. The spec was a 4,500 PSI shotcrete. Once we started to learn of the benefits that EdenCrete provided, we went out and we were like, we got to get involved here. We can help this. So we went in and we got a mix stamped that was submitted by AI and used by Thorcon for all 4,500 yards of shotcrete for Central 70. When we look at what we did, we took AI's mix here that's shown on the left in the reference, and we made the EdenCrete mix in the green. And essentially we dropped 152 pounds per cubic yard of cement from the mix. When we went in and we looked at the cost analysis for AI, the cost to use the EdenCrete mix versus the 4,500 that they had proposed was $4.40 cheaper to them, or provided $4.40 more profit per cubic yard to them. When we went out, we were doing things like this, right? 12 miles along I-70, we're expanding bridges, we're expanding underpasses, we're taking 45-degree abutments that you see there that are dirt. We clear them out. We use shotcrete to reinforce the caissons underneath. And then we take precast panel walls and put them up. And what this does is we add a lane of traffic, and we actually add a passenger walking sidewalk as well to actually expand capacity under these. And we did this along 12 miles of I-70. They did this underneath for bridges. They did it for soil nailed walls, on ramps, off ramps. This is right across from the dog food manufacturing facility. And it turned out incredible, right? And the use of EdenCrete ultimately provided the producer $20,000 more concrete, more money in their pocket. We saved 675,000 pounds of cement from the job. Ultimately, CO2 from EdenCrete only contributed 5.5 tons to the entire project. And when we look over here on the left, we saved ultimately 314 tons of CO2 from the Central 70 project, simply because EdenCrete makes it creamier and we could reduce cement and drop it 152 pounds per cubic yard. And now Central 70's got a carbon footprint story to it. And these things finished out, right? You drive around, you see all these precast panels, you have no idea that there's shotcrete underneath, right? It's not as beautiful underneath, but this is what's turned all of Central 70 into what it is. You know, these guys, when you have shotcrete, they oftentimes they're spraying into this steel formwork that you see, and that's a structural portion. And then they come out and they're spraying onto an area that they have to stamp. And so the creaminess is important, right? And so oftentimes they'll have two different mixes that come out to a job. They'll have a 4,000 PSI with a lower cement that's going to be used for the structural. And then they'll only use the 5,000 PSI because it has more cement. It's creamier. It's easier to stamp. But what happens is, what do you think shows up on the day they need the 5,000 PSI mix? The 4,000 PSI mix. And what do you think shows up when they need the 4,000 PSI mix? So they have problems, right? It's a logistical challenge and a headache. The wrong truck shows up. They have to throw concrete away. Because we created a mix that at higher strength will lower cement, they only request one mix. It's the EdenCrete mix. And it's a mix that makes 5,000, but has the cement content of the 4,000. And ultimately it stamps and it adheres for the structural. It solves all the problems, removes the logistical headache, and ultimately saves problems out on the job. When those guys get into bigger stuff, they can start doing things like this, carving really significant joints to do some really impressive stonework that requires kind of a special mix to be able to get to. Denver Broncos use it in every bit of the concrete that goes out there. Shotcrete, we use it in place of Zypex integral waterproofer and in place of fibers. We pour stuff up on the club level over drainage barriers where they have problems with cracking and abrasion. Similar areas, a lot of patchwork. That shouldn't be in there. Exterior applications where they're repairing for de-icer chemical scaling and cracking out there. What's amazing here is that I've just gone through 106 slides in the time that you all have been so generous with. And I didn't think I was going to get even to like 80. So, like I said, there's a lot of admixtures out there for concrete. There's a lot of really incredible technologies, and they all have a benefit, right? They're not selling and making money because they're not effective. But the unique thing about EdenCrete is that we provide more than one benefit. We're not just a shrinkage reducer. We're not just an air entrainer. We're not just a water reducer. And we provide a suite of benefits that help from the long-term performance and durability for your customer to the short term with morale of your crew and the ability to place concrete easily and not have to fight it and bear it, all the way up to the design for the engineer and potentially adjusting the design to have a lower carbon footprint, improve the sustainability for the owner, right? We've got about a single product that's providing benefits across 3 different stages of a project. And ultimately, it's giving you better concrete, right? So, I mean, the question becomes, at a certain point, the concrete industry has to open its eyes to some of these technologies and start to welcome them in, because it's going to be the only thing that's going to make our concrete keep lasting. You can't endure today's challenges with yesterday's concrete, with your father's concrete, right? That stuff doesn't work anymore. With that, does anyone have any other questions?
Okay, thank you, Robert. Any questions from the audience? Either type in chat or speak up now.
No, I have another question, if you don't mind, Robert.
Yeah.
So we are customers of Wholesale Aggregate Industries and Metro Mix, and I've spoken with our sales agent multiple times, and they've never recommended EdenCrete to us, little family-owned businesses. That I've never learned about you guys, and I've been in the business for about going on 6 years.
It's unfortunate, Hector. We've had dispensing systems in Aggregate Industries plants for 5 years. We're in Brannan, we're in Metro Mix, we're in Peak, we're in Summit Materials. We've got about 20 different concrete plants where we're Loveland Ready Mix, where we're installed here. Unfortunately, you have sales guys that are just the product of their environment, right? These guys aren't familiar with a lot of innovations. They're slow to adopt them. They feel like, it's honestly, quite frankly, with a lot of concrete sales guys, if it's going to require 3 extra sentences to have a conversation with you, Hector, it's not worth their time, right? It's more trouble than it's worth. And so It's a challenge. The world has, the concrete industry is stagnant, right? It's a slow to develop new technology industry. People lose jobs because a concrete yard costs them 2 cents more than what it does at another plant. And so it's a very frugal industry, right? I mean, cost is tough. And so there's a lot of folks that you have to understand why you would pay for that, right? And so the contractors that we work with through there, they get it. They use it. Right. They carry that price on to the owner, and they believe in it. And most of them develop a name of a product, and they don't even say EdenCrete, right? They just say, exactly. I just have a more durable concrete that's going to last longer for you. And they don't want to say it's carbon nanotubes or that it's a new technology, because the disconnect between the homeowner and the concrete sales guy and the contractor, they just want your expertise, right? If you say, oh, well, yeah, I've got a durable mix, but then there's this stuff named EdenCrete, they're made in Colorado, that doesn't work. If somebody asks you as the contractor, the producer, hey, Hector, man, I have this concrete driveway that's beat up. I need you to replace it because it didn't perform well. What should I do? Now, if Hector then comes and Hector says, what you need to use is use this mix that I've been using that is so durable and performs, and I haven't had problems, and it's got nanotech. That's what people on the side of, not understanding concrete, they believe your expertise, right? They believe what you're willing to suggest. That's where we start to convert. We have a lot of folks that use it without the name of EdenCrete and with the name of EdenCrete, right? So I could show you a lot of that. And Hector, if you're interested, I can show you a lot more on residential stuff that we do as well. My information.
Yes, sir. Also, one more. So how might we request EdenCrete? Because I've also spoken with Brandon as well, and we're big customers of SRM, the new Martin Marietta. And I've asked them, because a lot of our work is hand finished because it's residential, steps, sidewalks, walkways, all that stuff. And I've requested more, I guess, quote unquote, finisher friendly mixes. Okay. And all they propose is adding an extra sack of concrete.
Right.
Cement.
In a time when we have a cement shortage.
Exactly.
Right? In a world
I've
of
gotten
cement
orders
shortage.
that are canceled, you know, because there's not enough cement to produce for everyone else during the day.
Yeah. Hector, I'd love to have an explanation. They, you know, I mean, I take these guys to lunch. We got a sales guy. We take them to lunch. I was with them at NRMCA. We explain this stuff to these guys. Some of them, they're slow to adopt. Some of them they're intimidated by an innovation, a new technology. Some of them don't understand it. Some of them just don't take the time, you know, but I can assure you that if you're interested in talking with any of them and you want to use it, give me a call. We'll talk with them together. I can put you in touch with a sales guy at any one of those places. And we can absolutely get EdenCrete for you. You would need to do nothing more than call the sales guy.
Awesome. Awesome. And then I just have to mention you guys and see what they, you know, move on from there, I guess.
Absolutely. And I mean, again, call me if you want. We'll do it together. If somebody's giving you pushback, that would be news to me. And I would welcome having a conversation with them to understand why.
Awesome. Yeah, because I mean, I've got my contractor mixes with them. So that's just another whole financial deal. So we have to add EdenCrete and then do, you know, the numbers behind it. But yeah, definitely. Thank you. Thank you.
Hector, Hector, would it be okay if Mark shares your information with me, or Mark, can you share my information with Hector one way or the other?
Yeah, sure. I can, either one. Hector, if you send me an email, I'll forward you Robert's email, or we can, or.
Yes, sir. I'll message you my email right now here too.
Okay. All right. One technical question, Robert. So I'm in electromagnetics, right? So you said carbon nanotubes are conductive, right? Which they are. I was wondering, is there any effect on, for example, how signals, wireless cell phone signals, penetrate this concrete with, you know, EdenCrete versus traditional concrete?
No, Mark. So the carbon nanotubes are conductive at the loading that we have them in EdenCrete. We do not see them influence things like if we're in a switch station for a railway or a duct bank, right? Like something where we have some sort of things going through there, of wiring, electronics going through there. Back in the day, before we had settled on EdenCrete, when I was trying to figure out how EdenCrete didn't exist, right? I was working in a little lab trying to figure this out. I took and I made some EdenCrete that had a much higher percent carbon loading than what our current product has. I took and made 40 by 40 by 160 millimeter flexural strength beams, these little 3-point bending beams you do for mortar. I broke those, and then I did nothing more than take silver paste or electrical paste and put them on both sides with an ohm meter. Mm-hmm. And I attached the ohm meter to this sample, one with EdenCrete, one without. And the one without had a volume resistivity of 98 kilo ohms, I remember. Mm-hmm. The EdenCrete section had 2 kilo ohms. Mm-hmm. Now, that's not the product that we make today. I think that might cause problems. We don't put that level of carbon in our current product. But I've done some things in the past that, to a civil engineer who I do not understand your world, I think they seem to indicate a level of capability of the tubes. But you've got to remember, to get to EdenCrete required the path we took, right? You can't put carbon nanotubes into the hands of someone in a dry form, right? I could send you a bag of carbon nanotubes for free. I can't send you a bulk quantity of carbon nanotubes, because the EPA and NIOSH would be all over us just like that, because you're shipping cancer down the highway type thing, right? Mm-hmm. So we have folks that try to use it in different things, in plastics and whatever, but you have to get it into a form to be able to get it into whatever you're trying to use. For us, EdenCrete works well for concrete, and we use it for plastics. I'm not sure what you're thinking or where your mind's going there, but there might be an ability for us to put a formulation that's got a heavier content in there if that was something that you were looking for. But, you know, certainly you'd have to speak with the people smarter than me.
No, thank you so much. So let's all thank our speaker as much as we can. We really appreciate it. We're unfortunately at time. So this has been great, and really appreciate it. Next week, so we have another seminar next week. That's the Space Force seminar. Our Colonel Miguel Cruz will be talking about why the United States has a Space Force. So tune into that if you're interested, or if you're in the class, then you better tune in. Okay, well, thank you, Robert, and we'll be in touch.